Today we are going to be looking at section 4 of this chapter 6, looking at properties of rhombuses, or sometimes they'll use rhombi for plural, rectangles and squares. So the objectives are for you to be able to define and classify special types of parallelograms. So in section 2 that we covered last week, we talked about those properties of parallelograms. Rhombuses, rectangles, and squares all have those properties. They are a special type of parallelogram. And then be able to use the properties, specifically properties about their diagonals, that will help us solve some problems. So if you look at the rectangle flap in your interactive notebook, we have a number of properties, so I will give you time to get those written down. When we look at these properties of rectangles, these first 5 should sound familiar to you because those 5 properties are properties of all parallelograms. The last 2 are new and apply only to this idea of a rectangle. So the regular parallelograms that we looked at last week didn't necessarily have these 2 properties. But specific to rectangles are these last 2 properties. Rectangles have 4 right angles, which we know previously, and their diagonals are congruent. Because their diagonals are congruent and the diagonals also bisect each other, okay, all 4 of those pieces are going to be the same length. So that will be one of the key areas that we focus on as we work through some problems. So we've got a couple of examples to look at. So this first example tells us that quadrilateral RSTU is a rectangle. And the diagonals intersect at point P. Then it says if the measure of angle RSU, so angle RSU is 3x minus 5, and angle UST is 4x plus 4, find the value of x. So if we're looking at those properties of rectangles, what property could we apply to this problem that would allow us to write an equation and solve for x?
4 right angles.
Okay, rectangles have 4 right angles. So angle RST is a right angle. So these 2 smaller angles must add up to 90. So when I combine like terms, I have 7x minus 1 equal to 90. I add 1 to both sides, 7x equals 91, and then I divide by 7 to find that x is 13. Example 2 says quadrilateral ABCD is a rectangle. And the diagonals intersect at point P. For this problem, they tell me that AC, okay, AC is the entire diagonal. AC is 4x minus 13. And then DP, which is just half of the diagonal, is equal to x plus 7. So what can we do here to set up an equation? What kind of a relationship do we know about the yellow and the green marked up here? No, that's not going to help us. We're working with their length. What's the relationship between the yellow and the green? Okay, the diagonals are congruent. So from A to C and D to B, those would be equal. Okay, but we don't have the entire diagonal.
So it's half.
We have half of the diagonal. Okay. So if I wanted the entire diagonal, how long would DB equal? 2x plus 14, okay? So diagonal DB would be 2 times that x plus 7, which you guys just said was 2x plus 14, okay? I know the other diagonal is 4x minus 13, and those two diagonals are congruent or equal to each other. So if I subtract 2x, I get 2x on the left. I want to get rid of the minus 13, so I add 13 and get 27. And I divide by 2. I get 27 over 2, which is 13 and a half, or 13.5, since it's an ending decimal. Example 3 says quadrilateral JKLM is a rectangle with diagonals that intersect at point P. We know that LM LP, thank you. So LP is 3x plus 7, and MK is 26. We want to find the value of x. So what can we do for this one? Okay, we could do the same thing as we did in the previous example. So we found the entire diagonal LJ by taking 2 times the half that we have and getting 6x plus 14. So that 6x plus 14 has to equal 26. So I would subtract 14. 6x equals 12. I would divide by 6 and find that x is 2. Another way that we could have approached this one, since we know that those diagonals are bisecting each other, we know that all 4 of the pieces are equal. Okay? If the entire diagonal MK is 26, that means each piece is 13. So another option would have been to say that 3x plus 7 is equal to 13. Subtract 7 to get 3x equals 6. Divide by 3. We still come up with the same answer. So it kind of depends on what information is given to you. If it's got a variable in it or if it's just a number that is easy for us to split in two, that kind of thing. Another shape that we're going to talk about today is the rhombus. So again, I'll give you a minute to get this in your notes. As we look at the properties of rhombuses, similar to rectangles, these first 5 properties, again, are those properties we worked with last week with the parallelograms. So any parallelogram has these. A rhombus is a special type of parallelogram. The last 3 properties apply to rhombuses. So you notice they're different than what we had with rectangles. A rhombus has 4 congruent sides. The diagonals are perpendicular, and the diagonals bisect the opposite angles. So as that diagonal is drawn in, those 2 angles are being bisected, cut into 2 equal parts. So lots of information that we know about those rhombuses. So looking at our examples, it says if the measure of angle RST, so RST is 67, we want to find the measure of RSW, which is the red angle. So looking at those properties, how can I find the measure of angle RSW?
Are they consecutive, so they have to be 180? 180
No, we can tell they're not 180. They're not consecutive angles. Okay. Angle S and angle R or T would be consecutive angles of the parallelogram. So what's happening to angle S? It is being bisected, okay, by the diagonal. So half of 67 is 33 and a half, or 33.5. Example 2 says to find the measure of angle SVT. So we're looking for this red angle. They're telling us that STV is 135. Okay, STV is 135. They want us to find SVT. So a couple different properties we're going to apply here. So to start out, if I ignore those diagonals and I'm just looking at my rhombus, I know angle T in my rhombus is 135. How does that help me with any of my other angles? What do I know about angles in a rhombus? or angles in any kind of parallelogram.
They all
Okay, opposite angles are congruent. Okay, so angle R would also be 135. What else do I know about angles in a parallelogram? Consecutive angles are supplementary, which means angle V is going to be how much? 45. Because 135 plus 45 gives me the 180. So if my blue angle V is 45, how much is my red angle? Half of that, which is 22.5. So, as we look at this picture, okay, this is where we've talked before about, and some of you have questioned on some other things about not going by what the picture looks like, okay? In a rhombus, we know that all four sides are congruent. Our four sides don't look congruent. And the reason for that is because of the projector and how it skews the picture. Okay? Our angle WVT doesn't look like it is half of angle RVT. Okay? But based on what we know, okay, that's what we use. So that's what we mean about not being able to go by what the picture looks like. Okay? We can't look at its scale. Example 3 says the measure of angle SWT is 2x plus 8. And they want us to find x. What do we know about angle SWT? How is angle SWT being formed? The two diagonals. So what do we know about our two diagonals in a rhombus? They bisect each other. They are perpendicular, which means 2x plus 8 is equal to 90. So then I subtract 8, 2x equals 82, and divide by 2 to find that x is equal to 41. Example 4 wants me to find the value of x if the measure of angle WRV is 5x plus 5 and WRS is 7x minus 19. So what kind of a relationship do I know about those two angles? They are equal to each other because the diagonal is bisecting angle R of our rhombus. So I know that 7x minus 19 equals 5x plus 5. So if I subtract 5x, I'm left with 2x. I'll add 19 to get 24. So x is equal to 12. So those are the rhombuses or rhombi. And then squares. So again, I'll give you a minute to get these written down. When we take a look at these properties of squares, they all should look familiar to you. Again, these first 5 are those properties of any parallelogram. When we talk about a square, okay, it is even more special than the rectangle and the rhombus, because not only is a square a parallelogram, it has all of those properties. The next 2 properties are properties of those rectangles. Okay, so a square is a rectangle, which I think many of you have been told before. And it's just a special kind of rectangle. These last 3 properties are those properties of a rhombus. So a square is a rectangle because it has those properties. It is also a rhombus because it has those properties of a rhombus. So lots of different properties to think about when we are talking about squares. In this first example, tells us that the measure of angle AED is 5x plus 5. And they want us to find x. So what else do I know that will help me find the value of x for this first problem? Connor?
They're perpendicular, right?
Okay, they are perpendicular, which means they form a right angle. So 5x plus 5 is equal to 90. So we subtract 5x is equal to 85. And then we divide by 5 to find that x is equal to 17. This next example tells us that the measure of angle BAC is 5x, and we want to find x. So what can we do to find x with this one? I'm going to apply a couple different properties.
Wouldn't it equal 45?
Okay, 5x would equal 45, correct. Because we know, because of our rectangle properties, that we have 90-degree angles. We know that the diagonal is bisecting the opposite angles. So 5x is equal to 45, which means x would be equal to 9. In example 3, we are told that MH equals 8. We are looking for the length of AH. This one's a little bit trickier. So if we know one of the sides has a length of 8, what do we know about the other sides?
They're all 8.
They're all 8. And then we're looking for this AH, which is a diagonal. If we look at that diagonal with 2 other sides, we now have formed a triangle. More specifically, what kind of a triangle is it?
Right.
It's a right triangle. Do we know anything else about this right triangle?
sides are congruent.
We know two of the sides are congruent. If two sides are congruent, it means that their opposite angles are congruent. So those angles, I think I just heard it. What are each of those angles?
45, 45, 90.
They're both 45 because my right angles at the corners have been bisected. So if I think about my 45, 45, 90 triangles, if my leg is 8, my hypotenuse is 8 square root of 2. Okay? If you didn't remember those 45, 45, 90 triangles or didn't have your notes to be able to look at it, what else could we use to find the length of that hypotenuse? Right, Pythagorean theorem. Because it's a right triangle, we could use Pythagorean theorem. 8 squared plus 8 squared equals c squared. So 64 plus 64, which is 128. Just a lot more work to get to it. 12, we can do 2 and 64, which is 8 and 8. Since we've got a pair, we could stop there. So we've got 8 square root of 2. But again, if you take a little bit of time, recognize that it's a 45, 45, 90, then we can apply that rule and come up with that without doing that Pythagorean theorem. In this last example, we know that MS is 3, and we know that AS is 3. We want to find the perimeter of the square, MATH. So again, even though it doesn't look like a square, because our screen is stretching it out, we're told it's a square. So if I want to find the perimeter of a square, I have to add up all 4 sides or take a side times 4 because we know all 4 sides are congruent. So how am I going to go about finding a length of one of the sides?
45, 45, 90 triangle?
Okay, so what triangle is a 45, 45, 90 triangle? MSA, this triangle here? Yep, how do we know that that is a right triangle? Where's my right angle? Okay, angle S, because we have that property that tells us that the diagonals are perpendicular. So we've got that 45, 45, 90 triangle. So how long is side MA? 3 square root of 2. And if I have all 4 sides that are the same, then my perimeter is going to be 4 times 3 square root of 2, which gives me 12 square root of 2. So that was one way we could have looked at it. If you had trouble seeing that that was a 90-degree angle, we have other options. We could have looked at HAT as being a right triangle. And because we had half of the hypotenuse of 3, we know AH would be 6. So then we could still use our 45, 45, 90, with the 6 being the hypotenuse. If our hypotenuse is equal to 2 times, or I'm sorry, square root of 2 times the leg, it's leg times square root of 2. So we would have to divide by square root of 2, which means we have to rationalize. And we get 6 square root of 2 over 2. And we reduce that. 6 divided by 2 is 3. So again, we find a side length is 3 square root of 2, just like we did using that green triangle. So different ways that you can get to that answer using different properties of those special parallelograms. So the rectangle, the rhombus, and the square.